Okay, good afternoon to everybody. Today we discuss the uh, most important chapter of linear differential equation with constant coefficients. In previous lecture, we have studied about linear differential equations of first order and first degree. But today, actually, we will discuss about the differential equation of higher degree. Okay, first of all, what is linear differential equation? Linear differential is the degree of the dependent variables and of all derivatives is 1. Then the differential equation is called linear differential. So, if the degree yeah, so what is linear differential equation? If the degree of the dependent variable and all derivatives is 1, then then the differential equation is said to be linear differential equation. For example, this is actually second order differential equation because the higher derivative is what? Second derivative. But order is what? 2. But degree what? 1. Degree 1 and degree 1. Actually, dependent variable is what here? Y. Y is the dependent variable and X is the independent variable. Since there are single dependent variable and single independent variable, this is why it is also called ordinary differential. Okay? If there are single dependent variable and single independent variable, and it should be called ordinary differential. If there are more than one dependent variable or more than one independent variable, then those types of differential equations called partial differential equations. Remember, so if the degree of the dependent variable and all derivatives, the derivatives power what? 1. This derivatives power what? 1. This one and the dependent variable y power what? Single one. This is why it is called linear differential equation. Now, what is nonlinear differential equation? Okay. Second one is what is nonlinear differential? What is non-linear differential equation? So the equation is the opposite of linear differential equation. If the degree of dependent variable and or its derivatives are greater than 1, such differential equations are called one nonlinear differential equation. So if the degrees of the dependent variables and all derivatives is what will be is greater than 1. Okay, is greater than 1 is greater than 1, then the differential equation is said to be nonlinear differential differential equation. That means if the degree of the dependent variable or this may be like this or and or all derivatives of it is greater than 1, then the differential equation is said to be nonlinear differential equations. So in this case, for we can cite examples. Suppose a square y, x square, and another plus y square equals to sin x. Okay, actually this term I what second order. Okay, second derivative is y, but degree 1, and this also degree 1, but the highest power of y, highest power of dependent variable what 2, because that means greater than 1. This is why this differential equation treated as nonlinear differential. Okay, this is the example of so now, what is linear differential equation of order n? The differential equation of the form d nth derivative of y with respect to independent variable x plus pn p1 dn minus 1 of y dx n minus 1 plus p2 dn minus 2 of y dx to the power n minus 2 plus dot dot plus p and y. Okay, p and y equals to x, capital X. Where p1, p2, where p1, p2, p3 dot dot pn and x and capital X are the function of x, are the function of x or constants. Okay, then the differential equation is called linear differential equation, linear differential equation of order n. Okay, but for this we must remember that this is actually nth order because highest derivative is n times differentiation. So this is the nth derivatives, and this is n minus 1 derivatives and decreasing up to 0 derivatives. That means only single y. So dependent variable is single y, but the independent variable is what? X. This is why this is called ordinary differential equation of nth order. Okay, because highest derivative what? N. But degree what? Degree 1. Remember it. But here in these differential equations, actually p1, p2 dot dot pn, what will be? Function of x or constants only. Remember it. These must be function of x or constants. Then these types of differential equations called linear differential equation of order n. Now, the general form of linear differential equation of second order. Okay, second order because highest derivative is 2 here. So d square y dx square plus p dy dx plus dy equals to r. So from the general form of nth order linear differential equations, just we have taken two second order. For n equals to 2, this will be the form. So this is the p q r are the function of x or constants on. So this is the general form of linear differential equation of second order. Now if we can write ddx uh, equivalent to capital D, just operator, differential operator D, we can use using this operator D. Uh, this second order differential can be written as d square y plus p dy plus dy equals to r. That means taking y common, we can write d square plus d plus q equals to y. So this will give the solutions actually. For this complete solution, we have to remember that to find the solution, y equals to there will be a complementary function plus particular integral. Okay, this will be the solution for these types of function. Now try to find what is actually complementary function and particular integral. So how to find complementary function? Complementary function, how to find? Okay. Suppose you have to make this differential equation homogeneous. If right hand side is 0, then it will become homogeneous linear differential equation of second order. Okay. That means this we can write plus u y equals to 0. For finding complementary function, we have to make it homogeneous. Okay. Suppose let y equals to e to the power c1 e to the power m x be the complementary function. Complementary function of these two. Okay. Of two. So this can be written as for this just differentiating. First time differentiating, we get the value of dy dx, and second time differentiation, we get also the value of d square y by d square equals to what will be m square c1 e to the power m. Okay, so this can be written as just putting those values we get. So y equals to what here? Y equals to this. So dy dx what will be? Dy dx c1 m e to the power mx, right? And d square y dx square what will be? Second derivatives. Second derivatives what will be? C1 m square e to the power mx. Now putting the values of putting the values of y dy dx and d square y d square in equation 2. What will be the values? Just putting, we get this actually c1 e to the power mx m square plus pm plus q equals to 0. Right? Just putting all these values here, we get this values. Since the e to the power mx is not equal to 0, so from this we can write m square plus pm plus q equals to 0, which is called auxiliary equation. Auxiliary equation. Remember this. This equation is called auxiliary equation. This equation is called actually what is auxiliary equation. Now for this auxiliary, from this auxiliary equations, roots are real and different. Roots may be real or equal. So for different types of roots, we will try to solve different kinds of equation. Now let us try to solve an example for that. Suppose I have an example like this. Example 1. Solve d square y dx square minus 8 dy dx minus 8 dy dx plus 15y equals to 0. Now, how to solve this types of problem? Actually, here p equals to what? Minus 8 and q equals to what? 15. Okay. And second order differential equation and first degree. So, to solve these types of differential equations, we can write in this way. It can be written as, it can be written as like 8 dy plus 15 equals to 0. Okay. Or minus 8d plus 15 y equals to 0. Okay. Let y equals to e to the power mx be the solution. Be the solution. Solution. So auxiliary equation. Auxiliary equation. What? Just d square means what? M square. Okay. Second derivative minus 8m plus 15 into e to the power mx. What will be 0? This will be the very equation. Like this. Just putting all these values. Like this. So we get only this. Thus now solving for m square minus the middle term. Middle term what will be? Minus thrice m minus 5m plus 15 equals to 0. Or m will be what? M minus m 5 common m minus 3 equals to 0. Therefore, we get m minus 3 into m minus 5 equals to 0. So either m equals to 3 or m equals to what? 5. Okay. Now the solution will be what? For there are actually roots are different. Remember it. So since roots are different, the required solution is y equals to what will be? C1 e to the power m1x. Okay. And C2 e to the power m2x. This is the standard form of solution for the second order homogeneous linear equation. So C1 will be what? First constant e to the power m1. M1 is what? Thrice. And C2 e to the power m2 is what? 5. Okay. This is the required solution. So for roots for finding roots of second order linear differential equation. So roots, if the roots are real and different, y equals to what will be? First constant C1 e to the power m1x first root into x plus C2 e to the power second root into x plus C3 e to the power third root into x in this way. Okay. Now roots of real, if the roots are real and equal, then for equal, we have to write y equals to C1 plus C2x into e to the power x. Okay. If the division equation is third order, what will be C1 plus C2x plus C3x square, then e to the power. Now, if the roots are imaginary, that means complex roots, look like alpha plus I beta, then the solution will be what? E to the power alpha x into a cos beta x plus b cos b sin beta x. A and b are constant. Remember. So, how to find these types of roots? Now, we can try another example. Suppose example 2. Second order linear differential equation c minus 6 dy dx plus 9y equals to 0. This is the second example. Now this the differential equation, the given differential equation can be written as 6d plus 9 into y equals to 0. Let y equals to e to the power mx be the trial solution. Okay, trial solution. Then the auxiliary equation what will be? M square minus 6m plus 9 equals to 0. Just putting the value of d means for dy dx. Okay, dy dx what will be? First differentiation m e to the power x. Okay, Then second derivative is what will be m square e to the power mx. So putting these values, we get this auxiliary equation. Auxiliary equation. Now we can solve this auxiliary equation. This means what? M minus 3 whole square equals to 0. That means we get equal roots here. We get what? M equals to 3 and 3. That means roots are real and equal. So the required solution, what will be? Hence, the required solution is what will be? Y equals to C1 plus C2 x into what will be? E to the power mx. Mx means what? Thrice. E to the power thrice. Very easy. Okay. Now, for another example, for the third group, the example 3, d square y d square plus 4 dy dx plus 5y equals to 0. Now, this given differential equation can be written as what? D square and this will be 4d plus 5. Okay. So, let y equals to mx be the trial solution. Then the auxiliary equation what will be? M square plus 4m plus 15. Now, how we can solve this? How we can solve this differential equation? Actually, it cannot be. We can write using this one minus b. Minus b means what? 4 plus minus square root b square minus 4 c. M means what? 1. C means what? 15. Okay. Divided by twice a. You must know about this formula. Quadratic equation formula. Okay. 4 plus minus square root 16 minus 60 divided by 2. So we get this means what? Minus 40. Okay. Uh, this will be minus 44, right? Minus 44 divided by 2. Sorry, this will be 5. I am writing here 15. So this will be what? 20. Only minus 4. Okay. So from this we can write, we get actually what? Minus 1 minus 1 is I square. Okay. From the properties of complex number. So we get minus 2 minus 2 plus minus I. Okay. Minus 2 plus minus I. Therefore, after this line, the complementary function y equals to what will be? Y equals to e to the power, this is alpha. Okay, if we compare with this alpha plus I beta, then alpha equals to what will be? Minus 2 twice x. Okay, alpha equals to what? Minus twice x. Then m is what? M is what? Here I equals to 2. Here I equals to what? 2. 2 cos x plus b. B means capital B sin x. Here A cos x and B sin x. Actually, this is the complementary function for this. This is the result. and solution of this homogeneous differential. So the example is actually 4 D4. That means fourth order linear differential and homogeneous form. Let y equals to e to the power mx be the trial solution. Okay, trial solution. Then the given differential equation take the form what? Then auxiliary equation what will be? Auxiliary equation what will be? M to the power 4 minus m minus n plus 1 equals to 0. Okay. Now, how we can solve it for m? Taking m square m cube common, we get m minus 1 common, m minus 1. Okay. So, from this, m minus 1 also common, then m cube minus 1 equals to 0. So, from this, we get either or m minus 1. This a cube minus b cube formula for a minus b into a square plus ab plus b square. Okay, this equals to 0. That means we get here either m minus 1 equals to 0 or m minus 1 equals to another 0 or m square plus m plus 1 equals to 0. That means we get two equal roots. Okay, two equal roots, and another will be what? Complex roots. What? Minus 1 plus minus square root b square minus 4ab. B means 4a b divided by twice a. That means we get what? Minus 1 plus minus root over 3i divided by 2. Okay. That means minus half plus minus root over 3 by 2. Okay. So there are four roots from this from the equation. So the required solution is the required solution is y equals to what will be c1 c2x. Okay, e to the power what will be mx. M means what? 1. Okay, for the first two roots. Now another one, what will be complex roots. So e to the power alpha. Alpha means what? Minus half x, and another constant c3 cos root 3 by 2. Beta means what? Root 3 by 2 plus c4 sine root 3 by 2 x. This is actually solution of the given differential. Now another example for you for complex roots. This is the fourth order linear differential equations. Fourth order and first degree. So how to solve d to the power 4 plus dq minus 2 d square minus d plus d. Actually, d is the operator of the differential operator dx. So let us consider y to the power mx be the trial solution for this. Then the auxiliary differential equation of this. So auxiliary equation, auxiliary equation will be m to the power 4 plus m cube minus twice m square minus m plus 3 equals to 0. Now we can actually solve this for m. We get the after factorization we get m square minus m plus 1 and m square plus twice m plus 3. So either this equals to 0 or this equals to 0. This is the complex roots. For finding complex roots, we have to use the quadratic equation formula. Okay, quadratic equation formula you must know. If x square plus bx plus c equals to 0, then x equals to what will be minus b plus minus square root b square minus 4ac divided by twice. Okay, just using this quadratic formula here, we get here a equals to 1 and b equals to -1 and c equals to 1. Just put it here. And here a equals to 1, b equals to 2, and c equals to 3. So we get two complex roots here and two complex roots. So that means four roots. We got four roots because the highest order part fourth order. So we got four solutions. Remember it. And if the order of differential equation is n, then the solution will be what? N. So how to write the solution of this? The required solution is what will be the required solution y equals to can be written as e to the power alpha. That means if we denote this alpha plus I beta like this, so alpha means what? E to the power alpha means what? Half x, and first constant c1 cos beta means what? 3 by 2x, right? Plus c2 sin beta means what? Root 3 by 2x. Now another one for the another part of the solution, another two solution, e to the power what will be? E to the power what will be? Minus x. If we take alpha plus I beta for compare, alpha equals to what? -1. So e to the power alpha x means what? E to the -1x. That means e to the minus x. And third constant c3 cos beta means what? Root over 2 x plus fourth constant sine root 3 by 2. Sorry, only root over 2 beta root over 2 x. So remember this, there are how many constant here? 4 constant because order is 4. If order is 5, then there will be 5 constant. If order is 2, then constant will be 2. And if order is 7, the constant, how many constant will be? 7 constant. And if order is n, the constant how many? N number of constants in the general expression. So we have learned actually when right hand side is 0, that means if the linear differential equation is homogeneous form, then we can find the solution just by using complementary function and auxiliary equation. Now, if the right hand side is not 0, that means if right hand side is not equal to 0, then the solution will be what? The solution will be is what will be y equals to complementary function plus particular integral. That means we have to find the general solution. First of all, we find complementary function, then we have to add particular integral for this. Now, how to solve the differential equation by using particular integral? We'll try to understand this. First of all, rule 1. One by d minus alpha. Suppose we have constant alpha into x equals to e to the power alpha x 1 by d to the power minus alpha x into 15. Capital means I can say. Another one, rule 2, 1 by f of d, capital D is the operator dx, if e to the power x equals, this can be written as just substituting capital D equals to f. Okay, then it will become f of a e to the power x, but f of a can never be 0. Okay, so this capital T can be substituted by this. This is the another rule, second rule. And third rule also, rule 3, we can suppose we have a particular like this sine x, then each can be written as 1 by f of minus s square sine x, okay, or 1 by f of d square cos x. Similar, this will be 1 by minus plus substituting capital D square equals to minus s square cos x. This is the third. So now try to solve how to find the solution of linear differential equation whose right hand side is not 0. Okay, whose right hand side is not 0. Suppose, for example, 1 d square y dx square plus dy dx plus y equals to sine twice. Now, how to solve these types of differential equations? Because this is actually this is linear differential equation, but not homogeneous. Okay, not homogeneous. Linear differential equation because the highest degree of dependent variable and dependent variable is what? Single. And order also one. Order also self order. Let y equals to p to power mx be the trial solution. Then auxiliary equation what will be? You must know auxiliary equation what? M square plus m plus 1 equals to 0. Okay. Now after solving this, we can write using quadratic formula minus 4ac divided by, therefore m equals to what? Minus 1 plus minus over the I divided by 2. Okay. That means we get minus half plus minus 3 by 2 I. So the complementary function, therefore CF what will be? Complementary function what will be? Must know for complex roots e to the power alpha x. If it's compared to this complex number for finding the solution of function alpha x. Alpha means what? Minus half. Minus half c1 cos beta. Beta means what? Divide 2 x plus second constant sine beta x. This is the complementary function of the given differential. Now, particular integral. How to find particular integral? Particular integral or PI. Okay, particular integral means what? PI. We can write this particular integral as, this can be written as d square dy, okay, like this. D square plus d plus 1 right hand side. Okay, 1 by left hand side, 1 divided by left hand side into what? X. Particular integral can be written as what? You must know from the rule 1 by f of d into x. Okay, we have to write the particular integral like this. Particular integral to what? 1 by f of d. F of d is what? This is the divide dx means what? Capital. So just uh, in everywhere we have to use these concepts. So now how we can find this? you must know from the third rule, from the third rule, you must know f of d square equal to sine x. What will be 1 divided by f of minus s square sine x. Okay, so using this rule, we can write it x coefficient. Now x coefficient what? 1. Okay, x coefficient here a. So minus a square. So we can write d square means what? Minus 1 square plus d plus 1 sin x. That means 1 divided by only d. Okay, minus 1 and plus 1 cancel. Sin x. But 1 by d means what? Sorry, this is the sine twice x. I forgot. Sine twice x. So this will be minus 2 square. So minus twice square means what? D minus 3. Okay, d minus 3. So this will be twice x. Twice x. So now taking d plus 3 on both numerator and denominator, what will be d plus 3 divided by d square minus 3 square sine twice x. Okay, d plus 3 again using this rule. That means coefficient d square means coefficient minus coefficient square. Okay, minus coefficient square. What will be? Minus 2 square. Minus 2 square minus 3 square. What will be? Minus 2 square minus 3 square sine twice x. So after this line, we can write d plus 3 divided by 9 4 what? Minus 30 sine twice x. This equals to minus 13 differentiation of sine twice x plus 3 sine twice x. This equals to minus 1 by 30. Differentiation of sine means what? Cos. So 2 cos twice x plus 3 sine twice x. Okay, 2 cos twice x plus 3 sine twice x. Therefore, the required solution what will be? Required solution particular integral. Complementary function is this whole. Okay, e to the power minus half x c1 cos root 3 by 2x plus c2 sine root 3 by x plus minus 1 by 13 2 cos twice x plus 3 sine twice x. This is the actually result for this linear differential equation of second order. Okay, now another example whose right hand side is not equal to 0, that means exponential function. So d square y d square plus 6 dy dx plus 9y equals to 5 e to the power thrice. Now let us consider y equals to e to the power mx with a trial solution. Then the auxiliary equation what will be? Auxiliary equation will be plus m square plus 6m plus 9 equals to 0. Now how to solve this? How to solve this one? M square plus thrice m plus 9 equals to 3. Okay, mirror term factor m into m plus 3 plus 3 into m plus 3 equals to 0. Therefore, m plus 3 into m plus 3 equals to 0. Either m equals to 3, that means we get actually repeated roots. Okay, for repeated roots, what will be the complementary function? Complementary function will be first constant plus c2 into x e to the power what will be mx. M means what? Price. Okay, for repeated roots, for the second order differential equations, this is the rules for writing complementary function. Now, what will be the complementary, sorry, particular integral? D square plus 6d, capital D means what? Dy dx, plus 9 into 5 into e to the power what will be? Thrice x. Okay, so e to the power x rule, we have to use this rule, e to the power x rule. This will be coefficient square. So this equals to coefficient is 5, 1 by just e to the power x. M is what? 3. That means 3 square plus 6 into 3 plus 9. Just putting d equals to what? Just putting d equals to 3. E to the power thrice 6. So this equals to 5 divided by 3 square plus 18 plus 9. What? This will be 36. E to the power 5x. So the required solution is required solution is y equals to complementary function plus particular integral. That means what? Complementary function is c1 plus c2 x e to the power thrice x plus 5 by 36 e to the power 5x. This is the result. There are two constants only because the second order differential equation. Now another interesting example 8. This is the third order differential equations, but here right hand side is a capital X equals what? For minus x. Remember this will be case failure. We cannot use the rules of exponential function. So now let first of all find out the complementary function. So let y equals to mx be the trial solutions. Then the auxiliary equation what will be m cube plus thrice m square plus thrice m plus 1 equals to 0. So actually this is the formula of what? M plus 1 whole cube equals to 0. Therefore m equals to minus 1 minus 1 minus 1. That means 3 repeated roots. Okay. So the complementary function Cf, what will be complementary function? First, since there are 3 roots, 3 repeated roots, C1 to C2x plus C3, what will be? X square e to the power mx. M means what? Minus 1x. Okay. This is the complementary function. Now particular integral will be 1 divided by f of t. That means what? D cube. That means d plus 1 whole cube. Okay? E to the power minus x. Here, coefficient of x what? in exponential function, coefficient of x is -1. If we put a capital T equals to -1, this will be one, something by 0. Okay? Something by 0 means what? Case failure. Case failure. Okay? Case failure. So we have to differentiate this. How? Suppose differentiating denominator, then you have to put x in numerator. Then differentiation of this what will be 3 capital D plus 1 whole square e to the power minus 6. Again, if we put capital D equals to -1, then also case failure. Now again differentiating denominator and multiplying x with numerator, we get what? X square divided by 6 equals. Differentiating with respect to operator capital, okay? E to the power minus 6. Again case failure. Again case failure. If we put the coefficient of x in the place of capital D, we get something by 0. So we can again differentiating the denominator and multiply x with numerator. X cube 6 into 1 e to the power minus 6. Actually, this that means differentiating capital Q with respect to capital D 1. So we get what? X cube by 6 e to the power minus 6. So in case of case value of exponential function, we can proceed in this way. So there are solution will be what? Complete solution will be solution y equals to what will be complementary function plus particular integral. Complementary function c1 c2x plus c3 x square, polynomial on constant e to the power minus x plus x cube by 6 e to the power minus 6. This is the complete solution of the differential. So another example, 9 second order derivations. D square y d square plus 4 dy dx plus 4y equals to e to the power twice x plus e to the power minus twice. So let y equals to e to the power mx be the trial solution. Then auxiliary equation. Auxiliary equation, what will be auxiliary equation? M square plus 4m 4m plus 4 equals to 0. So after solving this actually repeated roots because m plus 2 square equals to 0. So m equals to what? 2. That means repeated roots. Therefore, the complementary function, what is the complementary function equals to c1 plus c2 into x plus e to the power mx. Means what? 2. Okay. This is the complementary function. Now, particular integral, what will be? Particular integral 1 divided by f of t is what? This d square plus 4 capital T plus 4 e to the power twice x plus e to the power minus twice. This is the right answer. And ddx means capital differential. So this means we can write e to the power twice x divided by t plus 2 whole square plus to the power minus twice x divided by t plus 2 whole square. But here for exponential rule of finding particular integrals, if we put the coefficient of x in the place of capital T, the denominator, we can write e to the power twice x divided by 2 plus 2 whole square. Okay? But in the second term, if we put the coefficient of x in the place of capital T, we get something by 0. That means undefined. So case failure for the second part. So we have to write what? Multiplying x with the numerator and differentiating the denominator with respect to operator d. So we get d plus e to the power minus twice x. So this means what? 1 by 16 e to the power twice x plus, again if we put coefficient of x in the place of capital D, we get another case value. So multiplying again with x in numerator and differentiating the denominator with respect to capital D. So we get 2 into 1 to the power minus twice x. So we get, this is the particular integral, therefore particular integral is this. Now the complete solution, hence complete solution is y equals to what will be complementary function plus particular integral. So complementary function is what? C1 C2x into e to the power twice x plus half x square e to the power minus twice. This is the complete solution of the given differential. Very easy question. Okay, now another example. If the right hand side, that means x is the multiple of the function. But if it multiple of two functions, to this step is how we can solve the linear differential. So in the right hand side, here right hand side is for x. This is third order differential equation, linear differential equation. D cube y dx cube minus 2 dy dx plus 4y equals to e to the power x cos x. But not homogeneous because right hand side is not equal to 0. So the if y equals to e to the power mx be the trial solution, then auxiliary equation what will be m cube minus twice m plus 4 equals to 0. Now we can solve this for m. That means this can be written as minus twice m plus 4. This equals to, so using a remainder theorem, we can write this one. That means m plus 2 into what will be square minus twice m plus 2 equals to 0. So either m plus 2 equal to 0 or m square minus twice m plus 2 equals to 0. Therefore, m equals to what? Minus 2, and m equals to what? Here, there will be two complex roots. Okay, that means m equals to 1 plus minus I. Right? So the complementary function what will be? Complementary function C1 into power minus twice x plus what will be e to the power alpha x, that is only 1 into x. C2 cos x plus C3 sin x. Okay, for complex roots, we can write the complementary function like this. Now, particular integral will be 1 by d cube minus twice d plus 4 e to the power x cos x. So, how we can write this? For multiplication of roots, for multiplication of functions in right hand side, for this multiplication, if we put this exponential function before this, we can write coefficient d plus 1. That means capital T plus 1. Okay, D will become D plus 1 minus 2D plus 1 cos x. Okay, that means using e to the power alpha x. Alpha means what? D plus alpha. So just using adding the coefficient of x from the exponential function in the operator. So this can be written as d plus 1 and minus 2 plus 1. What will be? We get d cube minus 3d square plus d plus 3 cos x. But remember that if we put the d square equals to minus 1, d square equals to minus 1, that means coefficient of x what? In cos 1. So if we put the d square equals to d square equals to what? Minus 1 square, then it will become case value. Case value. Okay. This is also minus 1, minus plus 3, minus 1 square, minus t plus t will be 0. So this also 0. Okay. So this will become case failure for that. Now for the case failure, we can write this e for x 1 by differentiating the denominator with respect to capital B, what will be minus d plus 1 and multiplying with the numerator x cos x. Now e to the power x divided by, now we can put d square means what? Coefficient of x square. That means 3 into minus 1 square minus 6d plus 1. Okay. So e to the power x divided by 3 plus 1 part 3 plus 1 minus 3 minus 3 6d minus 2. Okay. 6d this will be minus. So minus 3 plus 1, that means what will be? This will be plus, this will be plus, that is take plus 6d. So we get 6d minus 2 cos x e to the power x. Now to remove 6d minus 2, we can take 6d plus 2 in both numerator, 6d whole square minus 2 whole square cos x e to the power x into, that means we get, if we put actually 2 common, if you take common 2, then it will be easier also. That means 2 common 3d minus 1. Okay. So taking 3d plus 1 both we can write. So 3d plus 1 divided by 3 into d square minus 1 square. Only 1. Now we can put easily the coefficient of x. That means d square equals to minus 1 square. So 3 minus x square minus 1 3 plus 1 cos x. This means what? Minus 3 minus 1. That means minus 4. And here another 2. And 3 square means what? 9. So we get actually what? 10. So 10. So e to the power x divided by 20 minus e to the power x 20. And 3 differentiation of cos x what? Minus sin x. Okay. Minus sin x plus cos x. So this is actually particular integral. So the required solution is y equals to what? Complementary function plus particular integral. Complementary function what? This c1 e to the power twice x plus e to the power x c2 plus c3 sin x plus e to the power x divided by 20 multiplying minus get 3 sin x minus cos x. So into x. There will be this is the result. So first of all, we have to find out the auxiliary equation, then solving for n, we get complementary function. So here only single root c1 e to the minus twice x, and for two complex roots we have to write e to the power alpha x, alpha is 1. If alpha plus I is the complex number, then for alpha 1, then constant cos I coefficient of x plus sine of x coefficient of I is 1. So particular integral what will be 1 divided by dq minus twice d plus 2. Okay. Then right hand side x. So for multiplication of two functions, first of all we have to aside the e to the power x. Okay. Then we have to add it coefficient of x from exponential function to the operator d. That means d will become d plus 1. Okay. Then after solving this, we get this one. Now, if we put d square equals to minus 1, if we put d square equals to what? Minus 1 square, then it will become x square. So we have to differentiate this and multiply x with numerator. Okay, so now we can easily put d square equals to minus 1 square. Okay. Then this will become simply minus 2. Now taking 2 common, we get thrice d minus 1. So thrice d plus 1, thrice d plus 1, taking thrice d plus 1 numerator and denominator, we get s square minus b square power 3 square minus 1. So we get 9 square. We can also put coefficient of cos, coefficient of x in cos, d square equals to minus 1. So we get minus 20 in numerator, then 3d cos x. And multiplication of cos x what? Minus sin x and plus 1 into cos x. And so this is the particular integral. Now the complete solution of this differential y equals to complementary function plus particular. This is the particular. So just continue this values. Okay, now another example for multiplication of two functions in right hand side. Example 11, solve d square y dx square plus 4y equals to x sin x. Now for finding the complementary function, let y equals to e to the power mx be the trial solution. Then auxiliary equation will be m square plus 4 equals to 0. So this means what? m square m equals to what will be m equals to plus minus twice I. Okay. Now complementary function will be what will be complementary function equals to c1 e to the power c1 cos twice x plus c2 sin twice x. E to the power 0x I am not writing because if we compare with alpha plus I beta, alpha is 0. So e to the power 0 will be 1. This is why the complement. Now particular integral will be 1 by d square plus 2x sin x. So this actually this is the this equals to we can write imaginary part part imaginary part of 1 by d square plus 2 x e to the power ix. You know, can we write sin x equals to what? Sin x equals to e to the power ix imaginary because sin e to the power ix means what? Sin x cos x plus I sin x. Okay, cos x plus I sin x. Do you know? This is the imaginary part of this. So imaginary part of what? E to the power ix. Understand? In complex number, e to the power ix equals to what? Cos x plus I sin x. So real part is cos x, imaginary part what? Sin x. This is why this will be the imaginary part of x e to the power I x. So imaginary part of if we take e to the power ix in left side to the power ix, then we can write d will become d plus I plus. So this means imaginary part of e to the power ix 1 by d square a plus b whole square formula and I square equals to what? Minus 1. So this means plus twice di minus I square means minus 1 square minus 1 plus 4 what will be 3 plus 3 into x. So this equals to imaginary part of e to the power ix into, and if we take 3 common from here, if we take 3 common, uh, 3 common, then it will become 1 by 3. Then it can be written as like this 1 plus 2 by 3 d plus 1 by 3 d square to the power minus 1. Can we write? Just taking common from denominator 3, we can write this. Then you can write convert it into inverse. But using binomial expression 1 by 3 e to the power ix binomial 1 plus x, this will be whole become x 1 plus x whole to the power minus 1. What will be 1 plus x square plus x cube plus x. You are put in this way. Okay, so this means what? 1 minus x means what? 2 by 3 into x, because 1 plus x to the power minus 1 equals to what? 1 minus x plus x square minus x cube in this way. This is the series, just using this series. So this equals to imaginary part of 1 by 3 e to the power ix multiplying x, we get 2 by 3 differentiation of x what? 1. 1 plus x plus x square plus 1 by 3 differentiation of x what? 1 minus x plus x square minus x cube. This is the series, just using this series. So this equals to imaginary part of 1 by 3 e to the power ix multiplying x, we get 2 by 3 So after this line, you can write imaginary part of 1 by 3 e to the power ix means what? Cos x plus I sin x. E to the power ix means what? Cos x plus I sin x. Then x into 2 by 3 coefficient of I twice di. There are di. So I will be another. So x minus 2 by 3 into I. So imaginary part what? I into I will be real part. And cos x into x will be also real part. So this would be imaginary part would be 1 by 9 thrice x sin x minus twice cos x. This will be the actually result for particular integral. Therefore, the solution, complete solution y equals to complementary function plus particular integral. Complementary function what? This one. C1 cos x plus C2 sin x plus particular integral 1 by 9 3 sin x minus 2 cos x. Actually, this means what? Cos x into this plus I sin x into this. Then we get full term. Then arranging real part and imaginary part, we get this as a imaginary. So this is the required solution for this. E to the power ix equals to cos x plus I sin x. This is actually Euler formula. Remember it. In complex number, we have to use this formula. This is the exponential form of complex number. Okay, exponential form of complex number. So from this e to the power ix, this is the imaginary part. Sin x is the imaginary part. Imaginary part of this. Imaginary part of ix. But if we put e to the power ix or I to the power ix, we have to add the coefficient of x from exponential function. So d plus I. Okay, we have to add the coefficient with the operator d. Then d plus I whole square means this. Then we have to make it. If we take the 3 common, then we get d square by 3, 2 by 3 di and plus 1. So arranging, we get this 1 plus 2 by 3 di plus 1 by 3 d square to the power minus 1. So this is actually 1 plus x to the power minus 1. If we consider this whole x, okay, just 1 plus x to the minus 1 what? 1 minus x plus x to the minus x cube. So 1 minus this. But d square means double differential. Double differential of x what? 0. More than 1 operator will be 0. This is why we are omitting all the term higher term. So x multiplied with 1 and differentiation of x what? 1. So 2 by 3 into I. Now e to the power ix means what? Cos x plus I sin x. Cos x plus I sin x. Now cos x into x. It is the real part. But cos x into 2 by 3 I will be imaginary part. Okay? So minus 2 cos x and 1 by 3, 1 by 3 is 1 by 9. And another one, I sin x into x. I sin x into x. So x into I sin x. X into sin x is the imaginary part. So 3 will be not here. So we have to take 3 because we have taken common 1 by 9. This is 1 by 9. 3 sin x, 3x cos x sin x minus 2 cos x is the imaginary part. So this is the particular integral for this. Now complete solution what will be? Complete solution y equals to complementary function plus particular integral, and this is the result. Now another example where three equations are multiplied to each other. Three equations are multiplied to each other. So this is the last example for you. You have to solve t square y dx square minus 4 dy dx plus 4y equals to 3x square e to the power twice x sine twice x. So for solving, let y equals to e to the power mx be the trial solution. Okay, trial solution of the given equation. So auxiliary equation, what will be? Auxiliary equation m square minus 2m plus 4 equals to 0. Therefore, m minus 2 whole square equals to what will be? 0. Therefore, there are two repeated roots, m equals to 20. So, complementary function what will be? C1 plus C2x into e to the power mx, and means what? 2 twice x. Now, particular integral what will be? Particular integral 1 by d minus 2 whole square 3x square e to the power twice x sine twice x. So, this equals to can be written as 1 by 3 into x square 1 by d square x square e to the power twice x sorry e to the power twice x to the power 1 by d square x square sine twice x. This equals to 3 imaginary part of 3 e to the power twice x 1 by d square x square sine twice x. Imaginary part of 3 e to the power twice x into 1 by d square x square e to the power twice ix, because e to the power twice ix equals to what? Cos twice x plus I sin twice x. This is the formula of complex number in polar form and exponential form. So this 3 into e to the power twice x into e to the power twice ix 1 d plus twice I whole square. D will become what? D plus coefficient of x from exponential form. But here 1 by d square becomes what? Because d becomes d plus 2. If you put it will go twice x in the here, then d will become d plus 2. 2 cancels, so 1 by d square. And if we take this equal to twice ix in before the 1 by d square, then d will become what? D plus twice x. Okay, d plus alpha form. So this means imaginary part of e to the power twice x to the power twice ix. This means what? D square plus 4id minus 2 into what? X square. Now, after this line, you can write after this line, This kind we can write imaginary part of 3 into e to the power twice x plus ix power twice ix. But if we take 4 common from here, 1 by 4, then it will become what? T square by 4 id minus 1. So this can be written as like this: 1 minus id minus 1 by 4 t square to the power minus 1 into x square. Okay, so imaginary part of 3 e to the power twice x e to the power twice ix by 4. This means what? Using the previous series, 1 minus id minus 1 by 4 t square. So 1 minus x, this means x. So minus means what? This will become plus. Okay? And omitting the higher term, 1 by 4 d square minus d square. So imaginary part of 3 power twice x power twice ix by 4 multiplying x square, we get what? X square differentiation of x, what will be twice x, so plus twice ix. And second differentiation is the second differentiation of 1, 2. So we get minus 2 by 2, minus 3 by 2. So imaginary part of 3 into e to the power twice x. E to the power twice ix means what? Plus twice x plus I sin twice x into 1 by 4 x square plus twice ix minus 3 by 2. Actually, just multiplying this with this, then taking imaginary part, this equals to, can be written as 1 minus 3 by 8 e to the power x plus x square minus 3 sin plus x 4x plus 2x plus twice x. So this is the result. So complete solution is y equals to complementary function plus particular integral. Complementary function what? Is c1 plus x c2 e to the power twice x, and this is the complementary function minus 3 by 8 e to the power twice x. This is minus 3 sin twice x plus 4 x plus 2. This is the result.